Okay, guys, so I just realized that I forgot to include the calculator command for that part A, so I'm going to go ahead and include that as well. If you don't want to use table A and work backwards from the z-score formula, you could have instead used that inverse norm function, INVNORM, from your calculator. So let's find that. It's in the same place as the as the normal CDF. So we go second distribution. Scroll down to inverse norm. Oh, I'm so sorry, I hit the wrong button. Oh my, I don't need catalog help. Second quit should get me out of here. Here we go, okay. So inverse norm, the area I'm interested in, again, it's that left area, is 0.95. My mean is, let's make sure I get it right this time, 20.8, and my standard deviation is 9.3. So if you enter all those in, I get 36.0971, which is very similar to what we got before. Of course, if I round to 2 decimal places, I get 36.10. So that is correct. So I'm going to go ahead and write down what commands I used. It was 0.95 for the area, 20.8 for the mean, 9.3 for the standard deviation, and that gave me 36.0971, which of course I'm rounding to 36.10. Okay. All right, and I wrote my sentence in there. A taxi out time of 36.1 minutes will be long enough for 95% of flights. Okay, so let's move to the new material. This is part B. It says what taxi out time is long enough or greater than 95% of the mean taxi out times from random samples of 20 flights. Okay, so I'm looking for a taxi out time. But I'm going to compare it to mean taxi out times from random samples of 20 flights. So I should have said what mean taxi out time is here. There should be another word in here, what mean. That's what your problems will always say. What mean taxi out time is long enough. So I'm looking at samples of 20 flights. Anytime you see that, you're thinking you're going to be talking about these sample means. So I know n is equal to 20. So the first thing I do is think, well, does this fit the central limit theorem? Is n greater than 30? It's not. So I say n is less than 30, so it doesn't work that way. But again, this original population was normally distributed. Go back up to my problem. Normally distributed, these taxi out times. So I can say, but the original population is normal, which tells me this sample mean distribution will be normal. So I can move forward with finding my new mean and standard deviation. So I have mu sub x bar is going to be equal to the original population mean of 20.8. That's nothing new. But my sigma sub x bar, the standard deviation for the sample mean, is going to be my original standard deviation divided by that square root of n. So I have my 9.3 divided by the square root of 20. All right, so let's type this on in. 9.3 divided by the second square root of 20. Okay, I'm going to round again. This would have me rounding to 2.08 with 2 decimal places. So my standard deviation is 2.08. Okay, so now I know it's normal. I know the mean. I know the standard deviation. I can draw my normal curve. All right, my center here is my 20.8. It's the same as the curve above so far, but it's when I add in those standard deviations that things get different. So now I'm going 20.8 plus my new standard deviation of 2.08. All right, that's my first boundary. I'm going to do it again and again to get 3 standard deviations above the mean. So 22.88. Yep, okay. And then 24.96, and then 27.04. Okay, I need to go 3 in the opposite direction as well. This is one of those times, if you don't really want to watch me calculate that, I am totally fine with you skipping over this part of the video until we actually get our calculations in. Just make sure that you've done yours the same way as I have done mine. So 18.72, 16.64, and 14.56. All right. So again, of course, I have to label my normal curve. N for normal, 20.8 for the mean, and 2.08 now for my standard deviation. Different normal curve, right? Different standard deviations. Okay. So again, I want that mean taxi time to be greater than 95% of all the mean taxi out times from random samples of 20 flights. So I'm going to sketch in 90% again, or sorry, 95%. Again, I'm thinking that's going to be a little bit, the boundary will be a little bit less than 2 standard deviations above the mean. And it's to the left because I want it to be, my value to be greater than 95% of other values. Okay. Oh, and again, that's an area of 0.95. All right, now remember, if this was a right area, this is when we would take 1 minus the right area to get the left area to look in table A, but we're lucky in this problem that we don't have to do that. We have the left area already. So we're gonna look for 0.95 again, which we know is going to give us that z-score of 1.645. I might just point that out one more time where I found that. I'm looking in the actual table. I'm not looking over here for 0.95 because I don't have a z-score, I have an area. I look to find the closest to 0.95 and realize this is a special case, right? The 0.95 is halfway between those two values. I follow the arrow down. It tells me to use a z-score of 1.645. Okay, so I write on my paper that from table A, I get a z-score of 1.645. I know I'm going to have to plug in. I don't have to write the z-score formula every time, but I just really want to emphasize how this is different from the previous problem. The previous problem we used our z-score formula with just the regular mean and standard deviation. Now we have z is equal to x bar. The value I'm interested in is the sample mean, and I'm subtracting the mean for sample means and the standard deviation for sample means. So I plug in what I know. I know z is 1.645. I do not know the sample mean. I'm looking for a sample mean taxi out time. I do know the new, well, it's not new, it's the same as the original population mean, but I'm looking for mu sub x bar, and then I know sigma sub x bar, which is 2.08. Okay, so I'm trying to solve that equation, so I'm going to multiply by 2.08 on each side. Okay, 2.0, it cancels there. I'm going to have x bar minus 20.8 here on the right. I need to multiply 2.08 times 1.645. Notice the standard deviation always gets multiplied by that z-score. I got 3.4216. And now I need to finish solving by adding the mean to both sides. So add 20.8. All right, so I get x bar by itself, and I add to my 3.4216 the 20.8. So 24. Again, I'm going to round here. I'm going to go with 24.22. Okay, so it would be a sample mean time of 24.22 minutes. And I will write out that sentence before I do the next problem.